Moving on to the next portion of this lecture, and yep, this one is going to keep going. We have one more after this, but that section isn't too long, so congratulations on making it this far. Now we're going to talk about different objects and different recognition systems. Well, specifically, we're going to talk about faces. And faces are special. Not just because they're faces, but when it comes to the brain, recognition of faces seems to have its own unique properties. So just a reminder going back, remember that agnosias are problems with visual recognition. We talked about perceptive and associative agnosias. So we're now going to add one more. This is prosopagnosia. And what matters here is this is a syndrome in which individuals lose their ability to recognize faces. Now, most people just stop there in how they're given these definitions, and I will say the rest even though it gives this away a little bit as we go through. But it also seems like this affects the ability to make other fine-grained discriminations within a highly familiar category, even though other visual abilities are intact. And we'll expand on that as we go on. Now, people who suffer from prosopagnosia can recognize daily things. You can give them a pencil and be like, what is this? And they'll be like, it's a pencil. Why are you asking me stupid questions? Well, they probably won't say that, but nonetheless, they're able to recognize stuff, right? You know, there can be a cat and they'll be like, that's a cat. But if you show them a photograph of a face, or even just have them look at the face of a real person, they can tell you stuff like what the gender of that person is or the approximate age, right? Are they old, young, middle-aged, so on and so forth. But they won't be able to tell you who the person is. They cannot recognize the face of the person. They know it's a face of some kind because they're able to report information about gender, for example, or age, or just features, I guess. But they cannot tell you who the person is. This actually makes me think, and I don't think I've ever seen any literature on it, but I wonder if they would be able to tell you about the skin tone of a person. My guess is yes, because many of them report just having disjointed perceptions of features on the face without being able to merge all the items of the face together. Much like the original apperceptive agnosia we talked about, in which people are not able to bind the individual features of common objects. Now, these people are not even able to recognize a picture of themselves. In fact, there are reported cases where they will look into a mirror and think that they're actually looking out of a window at a stranger, which is pretty wild. But otherwise, their visual systems seem to work just fine. Now, this has been strongly linked to damage in the fusiform face area related to the fusiform area we were talking about previously, and oftentimes if this is damaged, one will lose the ability to recognize faces. It should be noted, though, that there are a few rare cases where people are born without the ability to recognize faces, and some of them do not have a damaged fusiform face area, which just leads to further confusion about the processing of faces. But that is very rare. Most of the reasons for prosopagnosia come from damage to this particular area. Now, another key component about recognition of faces is that faces are tremendously dependent on the orientation in which they are presented, especially compared to other objects. And as we saw previously on that image of looking at the different portions of the right and left face area, fusiform areas, and how it changed based on orientation, we saw that some part did and some part did not. So we would expect that to some degree, items are dependent on their orientations, which is what we see with this blue line. This is number of errors on the y-axis. So when a house is presented, different types of houses, and we're having to say if it's a house or judge what type of house it is, when it's upright, we make fewer errors than when it's upside down, which makes sense. Things are oftentimes a little bit more difficult to comprehend when they're upside down. But for faces, this is much more stark. When they're upright, we almost make no mistakes. We're very good at recognizing them. But when they're upside down, we actually make even more mistakes than when common objects are upside down themselves. This just illustrates how dependent on orientation faces are. And if these two bar or lines do not convince you enough, let us check out a cool example. shall I say, a freaky example. So take a moment to just look at these two faces, right? And you can tell that they're not exactly the same. Something is a little bit weird about one of those faces. Now, let's see if you think it's weirder or not as weird when we flip it around. Right? Now one is really weird. But one doesn't notice how strange it really is when it's upside down. Crazy, right? Just going back once more to see the illusion. It is a little bit strange. I mean, if you really look carefully now, you can see that that mouth is upside down and the eyes are the opposite way as this, right? But it still just looks like a face when you're looking at it upside down. It's not that weird, actually. But this way it could be a Halloween mask that they've made out of an ex-Prime Minister of England, which is just pretty wild, right? This just goes to show you that the recognition of faces is very dependent on the orientation in which they're presented. So, since we seem so uniquely tuned to faces and we have such interesting patterns around faces, well, then there must be some kind of face recognition system in the brain, right? Especially since we can have an agnosia that's specific to faces. But, like pretty much everything we talk about, it's not that simple. Because people who suffer from prosopagnosia also have other types of disrupted function, as you will recall from the definition. It turns out that people who suffer from prosopagnosia have other types of visual impairments, of where they lose the ability to discriminate between categories that they know really well. So one person was an avid bird watcher, and they're reported to have lost the ability to see the difference between warblers, or warblers. Sorry for the typo. It's a type of bird. I added some images here to show you different types of warblers that are present in this continent, and just to show you that they're quite different from each other. We don't mean like different types of finches that only have ever so subtle different colors of their beaks, even though there are lots of varieties of finches of all different types of colors. So nonetheless, to us, when we look at this picture, we can see a bunch of different birds. And since we're of course not engaged in bird watching, we would in fact think that these are different types of birds entirely. This person, who is an avid bird watcher though, is very familiar with this category of birds. And when they started to suffer from prosopagnosia, most likely because of a stroke, not only did they lose the ability to recognize faces, they lost the ability to recognize the difference between these birds who all fit into a single class for them. Another patient is said to have lost their ability to recognize the difference between cars, and they're reported to have to read license plates sequentially until they find their own license plate in a parking garage before they know what car is their own. So that's pretty weird. So it's not just faces, it seems like, but something else is related to this region of the brain. And there are currently two competing theories. One, that the fusiform face area is just face specific, and that's all it does, and something else must explain these extra deficits. Another camp believes that the fusiform face area is not actually specialized for faces, but rather it is specialized for recognizing individuals or subtle differences in a category that we are very familiar with, which would be true for faces as well, because faces are pretty much the first things we ever see in this world, and for many of us, they're the last things we see as well. Okay, another weird property of face recognition. So until now, in the previous parts when we talked about objects and we talked about letters and words and so on, we talked about them as being built up from basic features into complete objects. It does not appear to be the case for faces, in at least the way that they're recognized. It seems like we recognize faces in a holistic fashion, meaning we pay attention to the entirety of the face at once and use those cues to understand what face it is, to recognize it. So instead of basic features like lines and angles and letters, it seems like what is much more important to us when trying to recognize a face is the relationships of the different structures on the face itself. How far apart are the eyes? How much below the nose is the mouth, how wide is the mouth, how high are the cheekbones in relation to the chin, stuff like this. The relationships matter much more than the actual structures. And to see how we look at the whole face and tend to disregard to some degree the individual features, please look at this face. Who is this person? Just giving you a moment to think about it. And if anything, if you don't recognize this person, at least does it look like a whole person? And now, of course, you're probably scrutinizing it carefully, and so you're like, something kind of weird is going on. Here's the same face with the top off-shifted slightly. Is it now more obvious that these are in fact two different faces? How crazy is it now when you can see the entirely two different faces? This is Harrison Ford and Tom Cruise, I believe. Just look at how different these faces are, but do you see both these people here? Even now that you know, it still kind of looks like one face, which is pretty wild. This is just further evidence, and many experiments have been done like this to illustrate this concept, that when we're looking at faces and trying to recognize them, we are somehow looking at the entire face and thinking, or not thinking about, but processing how they relate to each other, the various features on the face itself, and use this to recognize who that person is, or whatever the face applies to. Which is just yet another difference between how we seem to recognize faces and everything else. A last note about recognizing faces. So we've talked about prosopagnosia, which is the inability to recognize faces and other fine details inside a category, but they are the opposite people who exist as well. They're people who can or have unbelievably good recognition and memory for faces. You could call them super recognizers if you wanted. And they need only see a face once or twice and will be able to remember that face and recognize it whenever they see it. In fact, maybe a decade and a half ago now, maybe even longer, they actually created a unit in the London police force of these super recognizers, where they actually gave them tests and tested them out and found a few of them after someone brought this to their attention. And they created a new unit whose job it was to just look at mugshots and then sit through hours and hours of CCTV. And they were actually able to locate and apprehend all manner of suspects because they were able to just recognize the faces that they had seen in mugshots in the CCTV video footage. And now they didn't need to sit there and memorize and think about each of those faces. They could literally open a book that had 4 pictures on one page, look at the faces, move on to the next page, look at the faces, move on to the next page, and then reliably find them in hours and hours of video footage. So it turns out there's actually an incredibly wide range in our abilities to recognize faces. Some of us are unbelievably good, some of us are unbelievably bad, and like with most things, most of us are probably somewhere in the middle.